In level 2, we will be evaluating composite functions at integer values. That means we're going to plug a number into one function, get an answer, and then we take our answer and plug it into another function. So the way it works, if we look at this first example in part A, we are going to plug -1 into k first. So I start on the inside and I evaluate k of -1. So plugging -1 into k, we get 3 times -1 to the third power, which is then squared. You can just plug that in your calculator to get your answer, or if you would rather use order of operations, I would start on the inside. -1 to the third is -1, so we get 3 times -1 squared. 3 times -1 is -3 inside parentheses, so we get -3 squared, and -3 squared is +9. So k of -1 was +9. Now we take this answer that we got, +9, and we plug it into our next function. So we're going to find j of 9. And so plugging 9 into our function j up at the top, we get the absolute value of 3 minus 9. Inside the absolute value, 3 minus 9 is -6, so we get the absolute value of -6. And absolute value makes everything come out positive, so this comes out to be +6. And that's my final answer. Okay, so to recap, I plugged -1 into k, I evaluated k of -1, I got an answer, and then I took my answer and plugged it into the outer function j. Then when I did j of +9, we got 6 as our answer, and that's our final answer. Okay, for the next one, it's written in a different notation, but it actually means the same thing. The function on the left is the outer function right here, and then the function on the right, the m, is the inner function. So a better way to write this is j of m of 49. It means the exact same thing as this. That open circle is a symbol for function composition. So don't confuse that with a closed circle, which means multiplication. Okay, so for this one, I'm plugging 49 into m first. So the first thing I do is I evaluate m of 49. So I plug 49 into m up top, and we get -square root of 49. Since that negative's on the outside, it doesn't affect my square root. First I do the square root of 49, which is 7, but because of the negative, I get -7. Now I take that answer I got, -7, and I plug it into j. So I do j of -7. Plugging -7 into j, we get the absolute value of 3 minus -7. 3 minus -7 is +10, so we get the absolute value of +10, and then anything inside an absolute value comes out positive, so this will just equal +10, and that's my final answer. In this next part, we'll be evaluating functions in a table. So it kind of works the same way, where you start on the inside and you find your inside part. So the first thing I'm going to find is f of -1. Now remember that the number inside here is an x. So I go to my x column and I find -1. And then I go over to my f of x column and find the corresponding function value, which is actually like a y value, and I get the answer to that part. So f of -1 would equal 2. So that's the first part. Now that I found the answer to the first part, I take that answer and plug it into my outer function. So now I'm going to find g of 2. So I go back to my x column because 2 became my new x. And I find the 2 in the x column. And then I go over to my g column and find the corresponding function value, which is going to be 3. And that's my final answer. For the next part, it's the same thing, just written in the other notation. So I would recommend always writing it in the original function notation manner. So I would keep the f on the outside and then a parenthesis g of 1 and close your parenthesis. So 1 gets plugged into g first. It always gets plugged into the closer function, and then the answer you get gets plugged into your outer function. So first I'm going to find g of 1. So 1 is my x. I go to my x column and I find 1. And then I go over to my g of x column and find the function value that goes with it. And we get 0. Now 0 becomes my new x that gets plugged into the outer function. So we get, now I'm going to plug 0 into f of 0. 0 is my x, so I go to the x column, I find 0, and then I go over to my f of x column and find the function value that goes with it, which is 5, and that's my final answer. Then the last thing in level 2 is evaluating function notation in one more setting, and that is with a graph. So I have two graphs. I have an f of x graph and a g of x graph. And the function notation works the same way. G circle f of negative 1 is the same as g of f of negative 1. So the first thing I'm going to find is f of negative 1. And remember that the inside number is your x. That's your x value. So if we have an x of negative 1, I go to my f of x graph, and I go on the x-axis to negative 1, which would be about right here. And then I go, in this case, down to my graph, and I find the point on the graph of f of x that has an x value of negative 1. And I give the y value of that function, which would be negative 3. So f of negative 1 is negative 3. And that's my first part. Now negative 3 is going to become my new x that gets plugged into g, into the outer function. So now I'm going to find g of negative 3. So now I'm looking at my g of x graph, and negative 3 is my x, so I go on the x-axis to negative 3, which is about right here. And I go down to the graph and find the point that has an x value of negative 3, which is this point right here, and I give its y value, which is negative 2. So we get negative 2 as our final answer. And then one more example. For this next one, first I would find g of 2. 2 is my x, so I'm looking at my g graph over here. I go on the x-axis to 2, and then I find the point that has an x value of 2, which is down here, and I give its y value. It's negative 3, so g of 2 equals negative 3. Then negative 3 becomes my new x that gets plugged into f, so I find f of negative 3. And now I'm going to be looking at my f of x graph. So moving back over to this graph, and we find negative 3 on the x-axis, because negative 3 is my x, that's right here. And this time I'm going up to find the point that has an x value of negative 3, and its y value is my answer, and its y value would be positive 1. And that's my final answer.